I'm very happy to have you with me again, and right now we're going to be talking about the basics, an overview of how CNNs work. This is just an overview, and in next videos we'll talk about it in more details. And to start discussing how CNNs perform image classification, we need to understand what is an image. What is a digital image? And we'll start by a simple example, the grayscale example. And simply the image is just an array of numbers, and each number of those is just the intensity value of a pixel. So in this example, in this 10 by 10 example, we can look at each number of those. It's the intensity of the pixel. So look at the left, see this is a 0, and on the right it's a black pixel because we have low intensity value. So when the number goes higher, this means that this pixel is brighter, like more white. When the value goes more dark, when the value goes less, this means that it's more dark. So that is how the image works, how the digital image works. And actually the same thing applies to RGB images, which are the colored images, but it's simply 3D array, what we call a tensor. So it simply contains, it's like 3 2D arrays stacked together, like a 3D big array, what we call tensor, and each array of those 3 arrays stacked together corresponds to some color. So for example, an array is for red, and an array is for green, and an array is for blue. That is in the RGB images. Each one of those also has values for the intensity. So each 3 numbers per each array are stacked upon each other. Some have a value of, one of them has a value of red, and one has the value of green, and one has the value of blue. And when they are stacked upon each other, they get you a new color. That is how this works. Now we're ready to understand how CNNs work. When you hear this for the first time, it seems strange. You don't really understand it sometimes, but just hear it another time, think of it more, it will make sense. And by practicing more and more, it will make sense. When we start coding, it will make more sense. They take the image, which is an array of numbers. They then do some mathematical operations, like multiplying some numbers by others and adding others and kinds of things that we're going to talk about. And these other numbers that we're going to multiply with and add are called parameters. Now then we take this resulting array, which is a new array, after doing these operations, which are called convolutions. We take them and we start trying to smaller their size, make their size smaller. How is that done? Well, we use something called pooling. Sometimes you choose regions, like for example the first 4x4 region of this image. You choose the largest value, you just use it, take it, put it into a new array. You take the next 4x4 region, for example, you take the largest number, and so on. So you make the size smaller. You can even take the average. Whatever is just, you choose a region, and each region with a specific size, you do some operation to them, choose the maximum number, choose the average, and you put it into only one pixel. So you're choosing each bunch of pixels, each group of pixels, just like minimize them into only one, try to compress them into only one pixel, and use that pixel to make the size of the array smaller. You do that. You may do convolutions again after that. So you just do a series of operations like this until you get an array that is probably small. You take that array, you feed it into a dense layer. Now this dense layer is going to do the following. It's gonna classify. So it sees this lost array. It's gonna classify whether this is something or the other. It's gonna do the classification. Alright. Now comes a very important question. How are these parameters, how are they chosen, right? The numbers that you multiply and add with, how are they chosen? They're chosen through training. So when the model is being trained, you give it lots of images of cats and dogs, for example. It learns the difference of those by choosing specific good parameters. So it chooses good numbers, good parameters that it's gonna use for these convolutions, for these operations, mathematical operations, so that when it goes to the dense layer, it can produce good results. So it takes big number of images of, for example, cats and dogs. It starts using parameters and it starts changing them, those parameters. It first choose these randomly, start changing them until they arrive into a bunch of parameters that are good. It chooses a bunch of parameters that are good and that work well with this specific purpose, the cats versus dogs, and then uses them whenever you try a new image that was not on the training set. So you come with a new image that the model have never seen, you give it to the model, you ask it whether this is a cat or a dog. It's gonna look at this and use the parameters that have been already chosen in the training phase and do the convolutions, do everything, give it to the dense layer, and then it determines whether this is a cat or a dog. Actually, the same thing applies with the dense layer. It also has parameters to learn, like the convolutional layer, and it also learns it through training. That's it. See you. Have a good day.